Bismillahirrahmanirrahim. Assalamu alaikum, students. How are you? I hope everyone would be fine. I'm Iqbal Shoukat, your instructor of Biostats and Stats. If we talk about the term statistics, it is the science of collection, presentation, analysis, summarization, interpretation of the numerical data. In the last lecture, we talked about the discrete distribution. There was the hypergeometric distribution, then the Poisson distribution. Today, we'll talk about the normal distribution or the bell-shaped distribution. It is known with the various names. It is the normal distribution, bell-shaped distribution, unimodal distribution. It is the asymptotic curve. It is a single peaked distribution. The normal distribution, when the data would be large, then we shall apply the normal distribution. Before discussing the normal distribution, we'll discuss about the probability. In the last lecture, we talked about the probability, the chance variation, where we can't observe or we can't say anything with confirmation the same would happen. When the chances are equally likely, anything can happen. That is known as the probability, is the branch of mathematics is concerned with the numerical description of how likely an event is to occur or how likely it is the proposition or the given statement is true. The answer of probability, as we have learned many times, the range of the distribution or the answer of the distribution is from 0 to 1. 0 means nothing can happen, and 1 means exactly would happen. That means existence of something, surety of something, confirmation of something, that represent the 1. And when we talk about the 0, that means impossibility of the event. And when we talk about the probability concepts, it is the branch of mathematics, as we know, which deals with the calculations about the likelihood of an event which can occur, or the number can range from 0 to 1. 0.5 is considered as the equal odds of occurring or not occurring. As I told, in the probability, we can't say anything with confirmation. We have the doubt. We have our limitations over there. We are not confirmed about a specific situation, that is known as the probability. For example, if we flip a coin, so you can't say with confirmation head will appear or the tail will appear. Any term can take place that is regarding to the probability. What students will come to know about today's lecture, what would be the learning outcomes from today's lectures? Let's have a look. First of all, students will be in a position to recognize how and when we have to apply the normal distribution, what are the conditions of the application of the normal distribution. Then they'll be in a position to recognize the standard normal distribution. Then they'll perform regarding to perfect calculations with the normal distribution by using the Excel sheets. Then they'll be in a position to convert a normal distribution to a standard normal distribution. Then they'll come to know about the properties of the normal distribution. What is the difference between sample mean, population mean, under what conditions we have to apply the normal distribution, all based upon today's lecture. Then they'll come to know what is the special area under the normal curve, under what conditions we can accept and we can reject the normal distribution. Then they'll come to know what is the difference between sample variance and population variance, what variance and what mean we apply in the normal distribution. Normally, the population mean and the population standard deviation is being applied in the normal distribution. If we talk about the normal distribution, as I told, it belongs to the continuous data, large information. When the data would be large, samples would be large, then we shall apply the normal distribution. Then at the last they'll be in a position to calculate the value of the normal distribution or the value of z from the given table or from a table of the normal distribution. As in the start I told, normal distribution is known by its various names. It is known as the bell-shaped distribution, asymptotic curve, or a curve that is naturally vary into many situations. For example, the bell curve is seen in the tests like SET and GRE, and you'll observe the number of students who score there on the average regarding to C, while a smaller number of students will score a B or D, or an even a smaller percentage of students score an F or an A. It means that we can say that there exists a bell shaped. There exists a bell shaped or the asymptotic curve where half data exists to the right side of the mean and half data exists to the left side of the mean. As I told, the total area under the normal curve is 1. So that we can say that 50% exists to the right side and 50% exists to the left side. Or the zero point 0.5 value exists to the right side and zero point 0.5 value exists to the left side. Then further, if we talk about the normal distribution, a distribution that creates a distribution that resembles a bell, hence it is also known as the bell-shaped distribution or a symmetrical distribution where there exists a sequence. It will gradually will increase and will gradually will decrease. Half of the data will fall to the left of the mean and half of the data will fall to the right of the mean. Many groups, many organizations, many examination patterns, as well as when we have to calculate the height of the students, score, salaries, blood pressure, and so on, then we shall have to apply the normal distribution. Regarding to the normal distribution, it is a distribution which is being widely used to calculate the large data. Regarding to the normal distribution, as I told, it is widely used in business, statistics, and even the government bodies like Statistical Bureau, Planning Commission of Pakistan, and different departments who are related to the calculations they are using the normal distribution. Even Punjab Public Service Commission, Superior Central Service Center, they are following the normal distribution concepts because it is applicable. Where the bell shape would be generated, we shall apply the normal distribution, or when we have to measure the heights of the people, or when the measurements error would be there, blood pressure, points on a test, IQ scores, EQ scores, salaries of the people, wage rate, then we have to apply the normal distribution. We have to sort the extremes. Very least data, very least information will apply on both extremes. It would be less than 2% or 3% on the both extremes. Or even we can say that less than 5% data exist on the both tails, and rest of the data, 95% data exist between these range. Now, if we talk about the binomial distribution and the hypergeometric distribution, they were the discrete distributions, or they were depending upon the discrete events, discrete variables. If we talk about the discrete data where there is the lacking of symmetry, lacking the sequence, any value, any positivity or any positive value may occur. That is regarding to the binomial distribution and the hypergeometric distribution, where we can say that the values are being infected and the values are not being affected. Whereas if we talk about the normal distribution, it is a probability density function for a continuous variable, for the continuous events, for the continuous values, or represented by a continuous curve. If we talk about the density, strength, It is the relative frequency of varieties on the y horizontal axis. If we talk about the normal distribution, as I told, it is widely used in the calculation of the height of the people, then measurement errors, blood pressure, IQ scores, or then we talked about the salaries, the wages regarding to the normal distribution. Then, what would be the main properties of the normal distribution? They should be kept in mind so that proper implementation of the data should be there. First of all, it is the bell shaped distribution. As in the start, I told, it is known by the different names: bell shaped, unimodal, single peak model, asymptotic curve, symmetrical curve, or the normal distribution. All depends upon the shapes. When the distribution would be formed, it would look like a bell shaped. So that it is known as the normal distribution, bell shaped distribution, or single peaked distribution, or it is a symmetrical distribution. It is not skewed distribution or non skewed distribution. It wouldn't be positively skewed, it wouldn't be negatively skewed, it would be just the symmetrical, or the sequence would be there, where the value beta 1, that would be equals to 0, the mean, median, and mode are identical at the point of origin. At the starting point, mostly the values of mean, median, and mode exist at the center point or the center values. Then the curve is asymptotic to the x-axis. It means that the curve will touch the x-axis on both tails regarding to minus infinity and positive infinity. So that we can say that the range of the distribution is from minus infinity to positive infinity. The values can be in points, the values can be in hundreds, thousands, lakhs, millions, billion, trillions, whatever the value would be there. Regarding to the large distribution, we shall apply the normal curve or the normal distribution. Then the curve has the point of inflection at mu minus sigma and mu plus sigma. If we talk about the point of inflection, it is a point, it is a condition, it is a situation where we are unable to decide a specific point, a specific condition, the turning point of the distribution, that is known as the point of inflection, where we are unable to decide about the specific situation, that is known as the point of inflection. Or when maximization converts into minimization, or minimization converts into maximization, that is regarding to the point of inflection. Regarding to the given distribution, regarding to the normal distribution, what values we have to keep in mind? First of all, we will keep in mind the concept of the population standard deviation. A standard deviation shows variation in data, scatteredness in data. If the value of standard deviation that would be more, data reliability would be less. It means that there are more variations, there are more scatteredness in the data, so or reliability on the data that would be lesser. And when the value of the standard deviation would be lesser, the values are clustered, they are mingled, or we can say that there are lesser variation in the data and our reliability on the data would be more. The quadral deviation regarding to the normal distribution, that is always two-thirds of its standard deviation, or even in normal situation we can also say that it is equal to 0.6745 into sigma. Regarding to the quartile deviation, the value which divide the upper quartile and the lower quartile difference into two equal parts, that is known as the quartile deviation. Instead of going into the depth of the quartile deviation, just simply remember the quartile deviation in normal distribution would be two-thirds of its standard deviation, or that would be 0.6745 of its standard deviation. Then, if we talk about the mean deviation would be 4 over 5th of its standard deviation, or that is further 0.7979 of its standard deviation, or even you may write 0.8 into standard deviation. 0.7979 approximately is equal to 0.8. So that we can say that 0.8 into sigma, that is also the mean deviation. Then for the distribution, the odd moments are always equal to 0. That would be m1, m3, m5, or mu1, mu3, mu5. They'll always be equal to 0. Whereas mu2 will represent the variance, whereas mu4, which is equal to 3 times into sigma raised power 4. Then the distribution is mesochotic. That is the value of beta 2, which is equal to 3. There are the three shapes of the distribution. One can be the platychotic, second one is the mesochotic, third one is the leptochotic. The shape or the height of the distribution depends upon the value of the standard deviation. If the value of a standard deviation would be more, as I told, variation in the data would be more, so the height of the distribution will be more. And when the value of a standard deviation would be lesser, there would be lesser variation in the data, and the height of the distribution would be lesser. And we have taken it as a beta 2. If the value of beta 2 would be equals to 3, the distribution would be mesochotic, and when the value of beta 2 would be less than 3, the distribution would be platychotic, and when the value of beta 2 would be more than 3, the distribution would be leptochotic. So we can say that regarding to specific conditions, probability of A that can be less than X or less than equals B. Here we are going to bound the area, the range of the distribution, the spatial area of the distribution would be equals to what? Let's have a look. On the next property, probability of mu minus sigma less than X less than equals mu plus sigma. Or in simple words, we can say that mu plus minus sigma, the total area of the distribution that covers this range, that is 68.26%. While on the other side, if we talk about mu plus minus 2 times standard deviation, that can be written as probability of mu minus 2 times sigma minus 2 times sigma less than X less than equals mu plus 2 times sigma, which is equal to 95.45%, which is further equals to 0.9544. And the last one is probability of mu minus 3 times sigma less than X less than equals mu plus minus 3 times sigma. It means the total area under the normal curve is 1, that is round about 0.9974, which is further equals to 99.74% or 74%. Now, with the help of a diagram, let's have a look regarding to the specific area. Here you can observe here is 1 times sigma, 2 times standard deviation, 3 times standard deviation. On the same case, minus 1 time standard deviation, minus 2 times, minus 3. For more clarification, let's have a look on the next diagram. Here is 1 times sigma, 2 times sigma, 3 times standard deviation. Again, the minus 1 times sigma, 2 times sigma, and then 3 times sigma. So the range of the distribution from mu plus minus 1 time a standard deviation, that means minus 1 to positive 1, it will cover 68% of the data or 68.2% of the data. Then here is 2 times standard deviation, here is again the 2 times standard deviation. So the range between these two curves, minus 2 times mu plus minus 2 times standard deviation that covers 95% of the data, and then 3 times standard deviation that covers 99.73% the data, the given information or the given values. Now we will apply these information on a bell-shaped curve. Which sort of data, what percent of data lies within range? Let's have a look. The value of mu, mean, median, mode, they always lies at the center. Mean, median, mode, all are equal at the center point, so that it is known as the unimodal symmetrical model. The symmetrical, it is known as sequence or symmetry. On both tails, on both sides, the distance, the height, the length are the same, so that whether we are traveling on the left side or the right side, the area would represent the same values. In between range, you'll observe minus sigma or positive one time standard deviation. As I told, there exists 68.2% area, so that 34.1% area to the right side and 34.1% area on the left side. If you add these values, the total area becomes 68.2%, that is round about 68%. As I told, the total area under the normal curve is 1. It means 50% area to the right side and 50% area to the left side. Then 2 times standard deviation, the range from minus 2 times sigma to positive 2 sigma. That means this area from minus 2 positive 2. This area 13.6 plus 34.1, that becomes 47.7, or again over here 47.7. 47.7, that becomes 95.45% area. Or then at the last, you'll observe the extremes regarding to A grades or even the F grades. They represent very least values or the least terms. As I told in the start, the round about 5% area, that means 2.1, 2.1, which is equal to 4.2 plus 0.1 plus 0.1. So that means 4.6, round about 5% area exists on the both tails or at extreme cases, whereas the 95% area covers the middle range, whereas the extreme values would be very the least one or the minimum one. Next one, regarding to the standard normal variate of the normal distribution. If the values of mu and a standard deviation will be given, then it's okay, we'll use the same values. If the value of mean and value of standard deviation would not be given, we always take the value of mean, population mean, which would be equals to 0, and the population standard deviation, that would be equals to 1. So here in this formula, it is known as the normal probability density function, which can be read as 1 divided by under root 2 pi sigma square, or even it can be written as 1 over, if sigma or sigma square or variance would be square root, square would be cancelled, 1 sigma term would be there, so even we can write 1 over sigma under root 2 pi, under root 2 pi. Again I repeat, 1 over sigma under root 2 pi into exponent of raised power minus 1 over 2 into x minus mu divided by sigma square. Here you will see x minus mu over sigma, it is the standard normal random variable. It is known as the standard normal random variable x minus mu over sigma square. So the graph of the normal distribution has been shown in the next figure. The shaded area in the figure represent the probability that the variate takes a value between 0 and z. Here is the normal curve, normal distribution, where the values can take place from different range. Here you will observe The area can be read from the table of the areas under the normal curve corresponding to any positive z. The area from 0 to z can be read from the table. A table would be there regarding to standard normal curve, though we can say that there are the two parameters of the normal distribution with population mean mu and the population standard deviation which is equal to sigma. Then the standard normal variate, or for the any probability regarding to x, the standard normal variate can be made use of any term. The standard normal variate, as I discussed in the previous slide, it is the formula of standard normal variate or the probability density function, which is equal to y equals 1 over under root 2 pi sigma square or variance into exponent of this area. The maximum ordinate of the function would always be equal to at mu equals 0 or x is equal to mu. So whatever the value would be mu, we'll put the same value of x 0 minus 0, which is equal to 0, divided by sigma, which is again equal to 0, and square, which is equal to 0, multiplied by 1 over 2, which is equal to again 0, or then any variable or term raised power 0 that becomes equal to 1, so that this area or this side becomes equal to 1, and the remaining portion would be 1 over under root 2 pi variance or sigma square. The maximum ordinate of the any function would be equals to x equals to mu. So in the given values, in the given formula, what are the symbols they are representing? Let's have a look. Y is the height of the ordinate, mu is the population mean, whereas the sigma is the population a standard deviation, whereas the value of pi, which is the constant, that is 3.14159, and the value of exponential function or the natural log, which is equal to 2.718282, and x can be take on any value from minus infinity to positive infinity. For the proper understanding of the normal distribution, let's have a numerical example of the normal distribution. Before discussing the numerical example of the normal distribution, why the normal probability distribution like a line, they both have a mean or mu. The shape of the given normal curve results from different values of mu and sigma. The placement of the distribution would be determined by the value of mean, mu or mean, whereas the height of the distribution would be determined by the value of the sigma. If we talk about the mean or the mu, which determines the midpoint, whereas the standard deviation that represents the height or the spread of the dispersion of the scores, the larger the value of sigma, the more dispersed the scores, the smaller the value, the less dispersed the score. As I told, the value of standard deviation defines the reliability of the distribution. If the value of the standard deviation would be lesser, we'll depend more upon the data. And if the value of the distribution or standard deviation would be higher, the lesser dependence would be on the distribution or the data, because there is more scatteredness, more variation, more dispersion is there in the data, so lesser reliability would be there. If we talk about the numerical example, numerical terms, how to determine what proportion of a normal population lies above, below a certain level, let's have a look. If the distribution of Hobbit higher in normal distribution with mean, which is equal to 120, whereas the standard deviation or the value of sigma, which is equal to 20, here you see the height of the Hobbit, which is equal to 120 centimeter, half less than 120 and half that is more than 120. What is the probability of finding a hobbit taller than 130 centimeter? Here 130 is the value of x, whereas the value of mean, which is equal to 120, the value of sigma, which is equal to 20. Now we shall apply these information into a standard normal random variable, which is equal to z x minus mu over sigma, which is equal to x is the value of the given term, which is equal to 130, the value of population mean, which was given in the form of the question, that was the 20. Oh, sorry, there was 120, and the value of sigma, that was the 20. So we will insert the values 130 minus 120 divided by 20. The total result is 0.5. From the table, from the z table, we will come to know the value of 0.5, or at the point 0.50. The value is equal to 0.3085, which means 30.85%. There is a 30.85% chances the height of the hobbit that would be more than 120 centimeter. That means there are the least chances, least terms are there, the height of the hobbit would be more than 120 centimeter. As I told in the previous slides, 68.27% of the measurements lie within mu plus minus 1 time sigma or 1 time standard deviation. Whereas if we talk about the 99.73% area of the measurements lie within mu plus minus 3 time standard deviation. Hence, we can say that the 95% confidence interval of a sample, which is equal to x plus minus 1.96 into sigma, 50% lies within mu plus minus 0.67 into sigma, 95% lies within mu plus minus 1.96 into sigma. The range within 1 is 95%, that is confident that the true population mean mu is to be found. More reliability is there, more confidence is there, more value existence is there. So whatever the values we are calculating, we are measuring, that depends upon the value of mean and the standard deviation. In any normal population, if k, the number of independent factors, becomes large, the distribution produced by binomial expansion would come very close to the normal distribution. Or even in many biological variables behave like the same. If the sample increase or independent factors increase, they become closer to the normal distribution. When samples would be large, this occurs even when the factors are not strictly independent or not at all in magnitude of effect. Then you can see the variance as the sample size goes on to increase, the variance is going to decrease in all three cases. Or even the standard error, that is also decreasing with the increase in the sample size. So what a standard deviation and a standard error means? A standard deviation is the parameter of natural population. Even though real populations are constantly changing, its size reflects real natural variance. Big is not good. Big is not good. What does it mean? If the value of a standard deviation would be more, that means there is more variation, more scatteredness in the data. So our data reliability would be lesser. While on the other side, if we talk about lesser value of standard deviation, there is natural dispersion of the population, more data reliability would be there, we will have more confidence on the population, and we can use that population for the further proceedings, for the further calculations. Then standard error becomes smaller with the increasing sample size. When the sample size will increase, population size will increase, the standard error goes on to decrease. Therefore, it reflects the sampling effort, accuracy of the mean, accuracy of the average. Whatever the data has been given, that is the accurate one, that is the right one. both frequently reported, graphed in ecological, biological literature, standard smaller, so often favored, but note this is a wrong reasoning. Practically either okay if you state which is shown and report in. It means that whether you are using the term standard deviation or standard error, it shouldn't be the greater one. If they are the greater one, data reliability would be the lesser one. That's all from my side for the today's lecture. Now I would like to summarize what we did today. First of all, we talked about the normal distribution, the learning outcomes of the normal distribution. Then we came across what is the recognition of the normal distribution. Then we discussed about the properties of the normal distribution. Then we talked about the numerical of the normal distribution. Then we discussed what is the role of a standard deviation and a standard error in normal curve or normal distribution, and what is the role of the sample size with the standard error as well as the population standard deviation. In the next lecture, we will talk about the numerical of the normal distribution. Values would be calculated, and the students will come to know how we can find the values of the z from the z table, what is the way of checking the z table, how we find the values, and what are the conditions where we subtract the values, where we will add the values. That's all from my side. Inshallah, in the next lecture, we'll have a interactive lecture on the normal distribution where the students will be independent to ask the questions relevant to the normal distribution. Whatever they wish to ask, they may ask. They may discuss. So it is advised to the students go through the concepts of the normal distribution, the properties of the normal distribution, then the shape and what does it represent, so that it would be easy, it would be convenient for the students to understand the concept of the normal distribution. So that's all from my side. See you in the next lecture. Until then, take care. Allah Hafiz. God bless you.